I want to eat steak, but it's spoiled. But how does that happen at all? Let us discover all the factors. Surface area, temperature, catalyst, concentration, and pressure are the 5 factors. Just the word steak will know chemical reaction. Just the word steak. Just the word steak. Just the word steak. We'll know how to speed up reaction. Just the word steak. Let us know.
S. Surface area. When surface area is increased, especially to solid reactants, rate of chemical reaction will also be elevated. Increasing the surface area of solid reactant means increasing the space it will occupy. So the larger space it can occupy, the faster the chemical reaction and the higher chances of collisions.
In surface area, consider this as your container and this as your solid reactant. Having this huge or gigantic solid reactant means you'll have a low surface area. Also, when we put it in our container and in a reaction, it will have a lower chemical reaction rate. However, what we can do to increase its surface area is to break it down into smaller pieces, like this. Now, this is the smaller pieces of our solid reactant. And now, if we will use it in a chemical reaction, the reaction rate will now be faster, for it will occupy much more space.
T. Temperature. Hops. But before knowing more about temperature, let me first introduce you to kinetic energy. Kinetic energy is the energy of things at motion. So in chemical reactions, increasing the temperature or lowering it down can affect the rate of chemical reaction. Increasing the temperature will also increase the rate of chemical reaction, since kinetic energy is also increased, causing so much movement of the particles, leading to more collisions and faster chemical reactions.
In this scenario, let us use steak. When steak is exposed to hot environment, like outside the refrigerator or just on your table, it will be spoiled. In this, we can conclude that higher temperature can truly increase the chemical reaction rate. However, if you put that steak in the refrigerator, which is low temperature, chemical reaction rate will be reduced since it is in a cold environment.
E. Existence of catalysts. A catalyst speeds up chemical reaction, for it lowers down the needed activation energy for a chemical reaction to happen. Catalysts provide another track which just needs lower amount of energy for a chemical reaction to occur, thus increasing chemical reaction rate.
Chemistry aside, this word catalyst can be understood by this situation. Pedro and Ana became a couple due to Juan, who arranged a blind date for them. In here, Juan acts as the catalyst, and his impact is good. This does not mean that catalysts in chemical reaction always increases the chemical reaction rate. It can be the other way around.
A. Alteration in concentration. First, let us give meaning to concentration. It is the quantity of solute present in a given quantity of solution. Hence, increasing the concentration of reactants in a solution will also increase the chemical reaction rate, since more particles are ready to react. This will also increase the number of collisions in that particular solution or chemical reaction.
In here, we have the solvent and 5 grams of solute and 10 grams of solute. So, we will put first the 5 grams of solute, and we will now have a solution. solute in this solution has a wide gap from one another. However, if we add the 10 grams of solute in it, we will now have a 15 grams of solute in our solution. It will have a faster chemical reaction rate since the gap between the particles or the solute is little.
K. Keeping an eye to pressure. Increasing pressure in a chemical reaction with gas particles will also escalate the rate of chemical reaction, since the gas particles in a gas reactant are highly spread out. Thus, increasing the pressure in it will compress those particles. This will lead to little distance with one another and more collisions. Based on ideal gas law, one way in increasing the pressure is to decrease the volume of the container or reaction vessel the gases are in.
We have here two containers. Based on ideal gas law, one way to increase pressure is to decrease the volume of the container. This larger one, compared to this smaller one, has a slower chemical reaction rate, and this small one has a faster chemical reaction rate. We can also represent pressure in this, having a container and put a lid on top of it. And we will push that lid deeper and deeper in the container until all the particles of that gas reactant is compressed at the bottom part of the container.
Now we are equipped and knowledgeable about the factors of chemical reaction. Next time, we won't spoil any viand that our mother asked us to preserve. See you in our next episode with your LJ Amazing Chemist in this segment called Loving Lab.